Go Tweedledee and Tweedledum. That's going to be us.
Who's Tweedledum?
All right, here we go. 11.5.
That's a good one. I don't have an eraser.
All right, 11.5. This is products and quotients, part 2.
Part 2A.
Okay, so this is actually the product and quotient portion of it. No words, I'm just going to show you how to do it. Yesterday we talked about simplifying. The reason why that's really, really important is because in this, you've got all these methods and everything to multiply, but then at the end, you have to simplify. So when you're multiplying, look at that. If they're right next to each other, what does that mean? Multiplying. Both of these numbers are prime, yes?
Yes. Yeah.
Okay, so if this is prime and this is prime, then all you have to do is multiply. So 7 times 3 is
21.
So then it's the square root of 21. And you're done. But it gets better.
It does.
Let's say we have the square root of 14 times the square root of 21. Now, neither one of these are prime, correct? Okay, so what you do is we're going to want to do the factor tree of both. So we have 14 and 21. Joseph, what two numbers when multiplied give me 14? 7 times 2. These two are prime. Joseph, what two numbers give me 21?
7.
Those two are prime. Okay, so if I'm multiplying the 14 and the 21, instead of multiplying the 14 and 21, we do the factor tree of both to simplify. And you write out all the prime factors together. 2 times 3 times 7 times 7. So notice what I did is I simplified both of them and then wrote out all the prime factors together. How many, when we're simplifying, Kelly, do we circle?
2. So you circle 7, 7.
And then these two are your leftovers. So, Kelly, how would it be written?
2 times 3 outside the radical sign.
That goes on the outside?
That was on the inside. I'm so sorry.
No, that's okay. So, 7 goes on the outside, and she's right. 2 times 3 goes on the inside, which is?
6.
All right, so the answer is 7 times the square root of 6. So we got to remember that the leftovers go inside. Our groups go on the outside. Any questions? This is basically what we're doing. There's not a lot of strings attached or anything, but this, huh?
Pretty much exactly what I did yesterday.
Well, no, because now we're multiplying. Now, I haven't done a division yet, though. Let's do another multiplication.
Are we doing that tomorrow?
No, tomorrow's Saturday. Silly girl.
Yeah.
2 times the square root of 54 times 3 times square root of 15. Okay, so this is kind of different because we have numbers on the outside, right? Okay, so what we're going to do is we're just going to focus on the radicand. Again, these are not prime, so we're going to do the factor trees. Okay, Tanner, can you take that in the hall? Sure. Okay. What two numbers give me 54 when multiplied? Italia?
2 and
27. 2. That's exactly what I have, actually. And 27. And then what two numbers give me 27?
9 and 3.
9 and 3, and then of course we have 3 and 3. And then of course 15 is 5 and 3. Okay, just like before, we are going to combine all the prime factors. 2 times 3 times 3 times 3 times 3 times 5. I'll pause, let y'all catch up. All right, so Kelly, what do I circle?
The 2 3s.
And
another 2 3s.
And another 2 3s. So, now watch very carefully. You see these outside numbers? They're going to go on the outside. What else goes on the outside, Kelly?
The 2 3s. Pair the 3s.
So another 3 and another 3, right? What goes on the inside?
The 2 and 5.
All right, do y'all see where everything goes? The outside numbers stay on the outside, being multiplied. 1 from each of these pairs also goes on the outside. Your leftovers go on the inside. So what is 2 times 3 times 3 times 3? Raise your hand. Raise it high in the air if you know the answer. 54. And then what goes on the inside? Anyone?
10.
There you go. Make sure you have all this written down. Does anyone have any questions? None? Yes, Kelly.
So on the outside, you just multiply 2 times 6, which equals.
Where do you see 6?
Sorry.
2 times 3.
Times 3, and that equals 6. Then 6 times 3, which equals
18. And then 18 times 3.
Okay.
Yeah.
I didn't know that was like for sure.
Or I did it backwards. 3 times 3 is 9. 9 times 3
Well,
is
I mean, it's
27,
fine.
27
The
times
bottom
2
line
is
is
So
you.
did this thing.
Okay. The bottom line is you multiply these 4 together. Okay. Got it? Do you understand? Yes? Why are you staring at me? Say yes or no. Okay.
Stare.
All right, let's do another. Square root of 5 times square root of 10. All right, first of all, this 5, is that prime? Do we need to do a factor tree on prime numbers? No. But the 10 is not. But we know that 10 is 2 times 5, right? So we're going to write our prime factors, 2 times 5, but we're going to include this prime number over here. So you're just going to stick it on there at the end. Do y'all see that? Make sure you're taking good notes. If your 5 or your number is prime, you just stick it on the end here. Now, Kelly, what do I circle?
The 2 5s.
So what goes on the outside?
The 5. And then on the inside of the 2.
There you go. All right. Any questions? Natalia, you want to do one? Square root of 6 times square root of 42.
So they're both not
Oh, good.
So you do a factor tree for both of them. So for 6, it's 3 times 2, which are both prime. And then for 42, it's 6 times 7, which 7 is prime, and 6 is 3 times 2. So then you have 2 times 2 times 3 times 3 times 7. And then you circle the 2 2s and then the 2 3s. You get back with 7. So you put 2 times 3 on the outside of the and then a 7 on the inside. And so then it's 6 times the square root of 7.
Very good. I think you guys understand multiplication.
No division.
Nope, here comes division. Any questions on multiplication?
No.
Yeah, we have points.
Please make all the questions like that.
Okay, so now we're doing quotients. I'm going to put quotients. You ready?
Yeah. Sorry.
Let's say I have 25 over 4. Y'all ready? No. Look up here, look up here, look up here. Can 25 be divided by 4 evenly? No. Can I reduce this by any number?
No.
Like, can any number go into 4 and 25?
No.
No. So, I'm going to go ahead and separate it into 2 radicals. Now, is this a perfect square?
Yes.
What's the square root of 25? What's the square root of 4?
2.
And there's your answer.
Oh yeah, it's easy too.
We have to put the radicals down. Well, that's just the first function.
Look right here.
Okay.
There's no, you're taking it out of the radical. Perfect square, the square root of 4 is just plain old 2.
Okay.
Y'all see that?
Yeah.
Let's do another. How about if I had the square root of 45 divided by the square root of 5? Let's sit back and look at it. Are either one of these perfect squares?
No.
Are they? No, they're not. Neither one of these are perfect squares like these are. But can we divide 45 by 5? How many times can 5 go into 45, Atalia? 9 times. So 45 divided by 5 is the square root of 9. Right? Do y'all all see that? Kelly, do you see this? What is the square root of 9? And there's your answer. So sometimes you're not going to be able to do any division or reducing, so you got to break it up. Oh, look, these are perfect squares. Okay, we're done. Oh, this isn't a perfect square, but we can reduce or divide 45 divided by 5. But keep in mind the square root stays with it. And then we took it out of the perfect square. Yes, ma'am.
So, on the first one, where it has the square root of 25 over 4.
Yeah.
For the second one, is the first part the same thing as the square root of 45 over 5?
Yeah.
Okay.
The square root over the square root of 5. Square root of square root.
Well, like the
These are both, this is set up the
same
exact
thing,
same,
but like
yeah.
if we were to take this one back
Like to make it look
step,
like this?
take it, yeah.
Okay, so she's saying, would this be the same? Actually, yes, it would. You can even write it like this. What's 45 divided by 5?
9. Square root of 9. That's what I was.
Yep.
I was like,
Does that make sense?
yeah.
I was so confused when you put that on there. I was like, but isn't that like the? And I was like, I was confused.
Does this help?
Yes, because I
Okay.
didn't know what happened to
So-
the 5.
So technically you don't have
45 divided by 5 is 9.
Well, yeah,
to,
but
so you don't have to put it in that form. You can leave it.
Leave it like this.
if it's reducible.
Except if it's reducible, 100%. The thing is, if you don't notice that these are perfect squares. See, if looking at it this way and then looking at it this way, you start to see it. See what I'm saying? So either way is fine. Okay. And I will tell you, my Algebra 1 class hates division. They like everything but division.
why?
It's a little more detailed. The multiplication and simplifying, y'all notice it's not a big deal, right? Division, there's a little more into it. Okay. Let's do another. Square root of 18 divided by square root of 9. Joseph.
18 can be divided by 9.
How many times?
2.
So then you get the square root of 2, right?
Right.
Is this a perfect square?
No.
No. Can we simplify this?
No.
It's prime, correct?
Yes.
So then that's your answer. If it's prime and it cannot be simplified, you just leave it. If it's not a perfect square, if it can't be simplified, then you just leave it. Any questions? All right, how about this? Kelly, I want you to do this one. Square root of 8 divided by square root of 2.
Okay, so 8, 2 can go into 8 4 times, so just put that in.
So what's your square root of
4.
square root of 4, right?
So then that can be 2.
That's right. It's a perfect square. So you can remove the radical sign. My 8th graders, some of them are still having trouble. They will give me, and don't write this, okay? They'll do this, but they'll tell me, here, I'm done. I'm like, no. It is still in the radical. Don't remove that radical sign until you can. Do you see the difference? And I do. I have some 8th graders that are getting confused as to when, or they'll have this and then they'll give me this as their answer. And I'm like, no. They're missing the concept here. Do y'all see the difference? If you don't, raise your hand. Because like I said, I have 8th graders still kind of struggling with this. All right, Ty, you ready? Square root of 81. Square root of 81 divided by the square root of 16.
Okay, so 81 can be divided by 16.
It what?
I think it can be divided by 16. No, it can't.
I don't know.
No, it can't.
Be an investigator. Sit back. What do you
No,
see?
because if it was 5, it'd be 80. So no, it
Okay.
can't. So,
But even if it could, what do you see here? Be an investigator. What do you notice? Are they perfect squares? So what's the square root of 81?
9,
Square root of 16.
4.
And there's your answer. There you go. See, that's why my 8th graders get annoyed with division. Because with multiplication and even with adding and subtracting, which I will do next week, there's one way of doing it. There's one way of doing it. With division, you literally have to sit back and say, all right, what's the best method? First thing you do, kind of like with this one right here, I always tell my students, first thing you do is, do you see any perfect squares first? Or can it be evenly divided first? You got to see which is the most appropriate way. Sometimes,
Both.
huh?
What if there's both?
it'll still come out to be the same answer. But there's different ways of doing it, kind of like having the square root over the whole thing or part of it. There's different ways of doing it to get the same answer. So that's why I always say you gotta kind of be more of an investigator on this, sit back. With multiplication, everything, and simplifying, it's one way. There's not as much sitting back and having to analyze. You know what I'm saying? Division, there's analyzing, and just wait until you get into algebra 1. But yes, go ahead.
Would it be wrong if you were to make it into a mixed fraction?
You don't, no, it will never be wrong. No. The only time it's wrong to do that is when you're graphing. When we do slope, like remember rise over run, you can't put it into a mixed number, right? But here, you don't have to, but if you want to put it into a decimal or mixed number, because improper fractions make you crazy, it's fine. It's not wrong. It's never wrong unless it's a
It probably
slope.
makes it harder on you because you have to like get your book.
No, let me tell you something. This is what they'll have, but I can, with something like this, it's not gonna stump me. I can,
2
yeah.
and 1/2. Technically.
I can figure it out. But I'll also, sometimes I'll even write in here, because I have students that cannot deal with improper fractions because you've been raised, that's wrong. Tanner, am I right? Like even like 2 days ago or something, I was like, okay, I'm gonna give you the improper fraction, but next time when you're doing fractions, we gotta change it. That's why in our books, this is the answer, and yet when you're dealing with just fractions, they're like, no, that's wrong. You got to change it. Come on, make a decision here. That's why I wasn't going to count yours wrong, because unless they tell you, you're fine. Okay.
So, also, if you were to make it into a mixed number, like 2 and 2/4, in that instance, would you reduce to 2 1/2?
That wouldn't be 2 2/4.
So it would be
4 goes into 9 how many
2
times?
times.
What's your remainder?
One left. Okay, 2 and 1/4. Okay.
There.
We just have that.
I was thinking 10.
Yes, of course I would.
I was
No.
thinking 10.
I know. Okay, so y'all get that. Let's see, do we need to even go into our books? I think you got it. See, I'm checking. Oh, I do want to do something. Okay, so you have examples of everything that we did in multiplication. Let's open up your book. I'm not going to do too many. Because all of them you understand how to do for his class too. All right, I'm telling you, girl. School mama's going to unleash the fury if I see another email. All right, go ahead.
Oh no, we've already done this.
Okay, Kelly, you're going to have homework tonight because I'm still waiting on you opening your book, girl. Wake up. No, you're not. You're sleeping. Sleeping on the job.
How was
Oh my gosh.
You're sleeping on the job. Fired. You're fired. What are you doing? Oh my gosh. All right, go to, because we've done examples of all these things, go to 27.
It's not even on this page. What do you mean?
All right, okay, 474. Turn the page. All right, so it's 5 times the square root of 10 divided by the square root of 2. Ooh. Oh my gosh, eager beaver, Talia.
Yay.
All right, now Kelly and Joseph pay close attention here, okay? All right, Italia, what do you want to do here?
I don't know, can I not look at the 5?
You cannot look at 5. Okay, I like how you put that. Can I not look at the 5 right now? Guys, this is a normal number, right?
Right.
These are radical numbers.
Yeah, man.
So that's right, yeah, man. So when you're doing this, you cannot divide a normal 5 by a square root of 2. So, like Italia said, can I not look at it? Absolutely don't look at it right now. Focus on the radicals. All right, go ahead.
So 10 can be divided by 2, which is 5.
So how would you write that?
So you'd write 5 times, well,
Yeah.
5 times, okay, yeah. So 5 times the square root of 5.
There you go. Now, in this case, you're done. You're done. You're done. Say it with me now. I'm just kidding. You're done. All right, so you can't do like a normal 5 times square root of 5 and get some weird 25. That's not how it works.
25.
Yeah, that's not how it works. This is simplified. That's the answer. If this 5 is already simplified and here and everything, then there you go. You're done. Let's do one more. 31. Joseph or Kelly, raise your hand. Who wants to do it? All right, Kelly did it first. Oh, this is a little different. All right, Kelly, you go, girl.
Okay. 8 can go into 80 about 10 times.
Ah, but is this a radical 8?
No, it's not.
No, it's not.
Because I didn't see that.
Ah,
Then it'll just be a 10. Well, it'd be a radical 10.
no. This is a normal 8. That's radical. You cannot divide those. But what else can you do?
This is not good. I think I know.
Do you not know?
I don't know. I'm sorry.
All right, Joseph.
Maybe you have to divide 8 by 2.
Ah, well, you're not really dividing it, but you're reducing it. Do you see the 2 and the 8?
Yes.
So what would that be? 1 times square root of 80 over 4. Now, do we even have to have that 1 there?
No.
So it'd be square root of 80 over 4. Is 80 simplified?
No.
So we're going to have to do a factor tree. And to save time, because I want y'all to have time to do homework, 8 times 10, 2 times 4, write it with me. I'll let you catch up. Now, Kelly, do you understand why we did what we did?
A little bit. I don't understand the. No, I do know.
Do you see it? These are regular numbers, so those can be simplified. We got rid of the 1 because you don't need it. Do you understand now? It's because you cannot combine a radical and a normal number.
I was thinking that, but I was like, oh my gosh.
All right, so I have a 2 times a 2 times a 2, 2, and 5. So I circle my pairs of 2s. Now, remember, we're changing this. So look what I do. The 2 and the 2 go on the outside. The 5 goes on the inside, and it's all over 4, correct?
Yeah.
Write that down and look. Kelly, do you see that? Do you understand why I put a 4 under here?
It's because that 4 is still there.
That's right. This 4 is still here. And we took the radical square root of 80 and we've simplified it. So now that becomes 2 times 2 is 4 times square root of 5 over 4. Joseph, what do you see I can still do?
For one problem.
Shh. Joseph, can I do something here?
You can reduce the 4s.
Can 4 be divided by 4?
Yes.
What's 4 divided by 4? 1 times square root of 5. Do I have to have the 1 there?
No.
So then my answer is,
Square root of 5.
so I want y'all to notice, 2 times square root of 80 divided by 8 is square root of 5. Any questions? Yes.
So, where the 2 and the 8 are, what if it was a number that you could not be divided, like 3 and 7?
Well, if it was 3 and 7, then you would times square root of 80. You would do all this, put the 2 2's out here with the 3. You know what I'm saying?
Yeah.
And do your work. And if you can't divide it anymore, then you'd stop. You'd simplify it as far as you can, then you'd stop. For example, let's say it's this. If you end up here, oh look, I can't do anything with the 7 3, so that's my answer.
That's the easy problem ever.
Huh?
That's a really easy problem.
I don't even know what you're saying.
That's a really easy problem.
I heard that. It's a really easy problem. Play that.
I know, I heard that too.
I keep
All
on
right.
trying after a while.
Let's see, yesterday y'all did all that simplifying 7 to 12. So today you're doing okay, you're doing 10 problems. You're doing 13 to 31 odd. No, we did odd. I'm so sorry.
No, we didn't. No, we didn't.
I did 27 31. Yeah, huh?
You didn't. No, you didn't, Miss Rogers. Yeah. No, we didn't. Yesterday we did.
Look, girl.
Today.
Girl, I said today. We just did 31 27. I got to change it to even.
Miss Rogers, yesterday we did 7 through 12 all, and then 33 and 34. Oh yeah.
I know. And I just wrote 13 to 31 odd. And I just said we did 27 31.
Oh, there.
So I'm changing it to even.
No, make it
14. See, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Still 10. Due Monday. All right. Y'all got about 20 minutes. Huh?
I said gnarly.
Gnarly.